Hi, this is Dr. Malade. Today is December 20, 2019, my 53rd birthday, so consider it as my birthday present to you. So I have worked on a couple of games using VBA Macro in PPT. So here I present them. There are around 12 of them. I tried to develop, borrow in most of the cases I borrowed idea from different uh, concepts, and some are quite new. So let me start with plan to be a perfectionist. So we have a circle here which we can move using these arrows. The game is to put the circle so that the center of the circle coincides with the point P. So let me see how close I can go. Error is 5.23%. Let me see. 5.18%. No, it's digital, so 0% error may not be possible. So the challenge is to put the center of the circle as close as possible to the point P. So this is the first game. Next game comes with the game of sums. I start the game 7 plus 8 15. I need to choose the correct number. 7 plus 9 16, 5 plus 7 12, 3 plus 2 5, 8 plus 9 17, 9 plus 1 10, 9 plus 4 13, 5 plus 5 10, 1 plus 5 6, and I have completed 10 sums within how much seconds? I don't know. The seconds are important. Now again the similar type of game where it is not only addition but addition modulo the size. So 5 plus 5 0, 4 plus 1 0, 1 plus 3 4, 2 plus 5 2, 3 plus 2 0, 5 plus 4 9, which is 4, 2 plus 2 4, 5 plus 2 7, which is 2, 6, which is 1, 0, and I've completed 10 sums modulo 5. I have to complete around 34 slides, so let me be in a little hurry. Next is a memory game. You try to match the open squares. B has got a match. A has got a match. E, was there an E? I. L, G, I, D. So I have completed the memory game in 45 clicks. If it is more than 50, then it's good. I couldn't score more than 50. Predicting the possibilities. So you start with a random arrangement of numbers 1 to 8 in 3 by 3 square. Now you need to arrange them in order. So fewer clicks you need, the better is your game. On top of it, you have to predict whether it's possible or not. So I don't think it's possible. So otherwise I could have put green, but I don't think it's possible. So in half of the arrangements ends up with impossibility. So I'm correct. This is not possible. There is a twist in between 7 and 8. So this is not possible to arrange in the order 1 to 8. So I took 25 clicks to arrange the numbers, and on 12th click I could predict correctly that it's not possible. So that's the game of prediction. This is not a game, this is just watching a box, a color roaming around in a 7 by 7 grid. Now you can start with another color and watch them moving around. Once uh, you can watch them getting marched, which may take time. Oops, finally it got marched. A new color came of the mixture. Eight queen puzzles is a interesting, is a well-known puzzle. You have to play, this is a 8 by 8 chess board. You have to place 8 queens in 8 squares so that none attacks another. So let me start here. The next queen I can place here. The next queen I can place here. The queen in the 5th row can be placed here. Queen in the 6th row can be placed here. Queen in the 7th row can be placed here. But there is no more space for 8th queen, because if you put it here, they are in the same diagonal. So it is they are attacking. So you need to go back and try the next squares. That's possible because these queens are attacking. So this has got only one solution considering the symmetries, but I am yet to find that solution. Double or nothing is an interesting game. So you start with the reset, then go on tossing. As long as head comes, the pot gets doubled. If it is tail, it is zero. Otherwise, it gets doubled. So let me put 1600 as the game one. I have to finish 3 games within 30 seconds. Let me see how much I can score in last 24 seconds. Oops. Sometime back I scored 14,000, but this is not going to be anywhere near, it seems. No. Uh, uh, Oops, the game has ended. Seconds left -1. Otherwise, he could have, if you could finish, if I could finish 3 games within 60 seconds, I could have put one entry here in the history. So this is double or nothing. Then peg solitaire, well-known peg solitaire game. You start with all the pegs except the middle one. Then you go on then you go on clearing the pegs. This is a well-known solution that I got from the net. But there could be interesting modifications which I tried, but I'll demonstrate it. Now, finally, you end up with one peg in the middle. So you can try some random starting point, which is 13 pegs or more, say 16 pegs, and you could try to solve them. I don't know whether it's possible or not. Most probably it's not possible. You can try to solve them, and it will say whether it's possible or not. If it is possible, it will show you the steps. That's peg solitaire. Harmony is a game from tic-tac-toe. You can play a tic-tac-toe here. But the problem is most of the time it's a draw. Most of the time it's a draw. Now one can play in a larger board, say in a 4x4 with win length 4. So you have to make 4 in a row to win the game. Just demonstrate the idea. So here it will be a draw most probably if two players play carefully. The tic-tac-toe ends up in a draw. So they came up with the variation no tac-toe where one who makes 3 in a row loses. So let me start here. So player plays with same symbol. If I put my if I occupy this square, there is no other place, so it will be my win. If I move second, again I win. So one can play no tacto in a larger board. Similarly, it's an interesting game. There is one variation which I made is to place is just to occupy squares so that to see how many squares can be occupied at the most. So for 4x4 grid, it's possible to put 9. It's possible to occupy 9 squares with having maximum two maximum 2 consecutive boxes occupied in a row, column, or diagonal. One can play with that. One can play with larger board size. So 5 for 5, it is possible to maximum possible is 16. That's the maximum possible. For 6, I think it's possible to put 20. There is an app in Play Store in the name Harmony where this game is made in an app. Free app. One can try that if you like. Maximum possible is 20. Maximum possible is 20 for board size 6x6. For 10x10, the maximum possible yet known is 52. We don't know whether 53 is possible or not. Bagbandi is a nice game. You do with a start, you play with one tiger and you play as a goat. So let me see if I can trap this tiger. Don't think I'll be able to trap. So it will take time to trap the tiger. One can play as a goat or as a tiger, and one can play with more than one tiger. Say one can play with 4 tigers, maximum 5. It's a difficult game. Hmm. One can try to trap the tigers. So this tiger is trapped now. I have to trap these tigers, but there is no move. It will take time. The trap tiger game is the English version, you can say, where you start with say 2 tigers. Oops. And then try to place goat so that the tiger gets trapped. difficult. For more than one tigers is difficult. However, it's happening for me. And I could trap two tigers. Now this is in two-dimensional board. Now one can go to a 4x4x4 cube. It will be very difficult. Yellow means it's safe. It's safe to place the goat. You get the carve. It goes up. On x-axis it's the clicks, number of clicks, and on y-axis is the number of goats. So you have to play 64 minus 2. There's 62 goats to trap the two tigers. I have plans to convert it to an app, free app, and put it in Play Store. Finally, venture to unknown. So let me start with the concept of Latin square. So we have on the first row we have 0 to 6. The size is 6. I can change the size. Say for 6 by 6, the numbers are 0 to 5. On the first column is 0 to 5. Now there are some zeros here, and any number appears only once in the entire row or the column. So you have to fill up the square with that idea that any number can only come once in the entire row or the column. Let me try to place 3, as many 3s as possible. No. Then try to put 4. So the square is complete now. My score is 30. Maximum score was 34. Average is 27.38. So now, considering the Latin square, there is a concept called mutually orthogonal Latin square. So let me start from 1. Zero is the only Latin square. For 2 by 2 case, this is case 1 by 1. For 2 by 2, 0, 1, 0, and only possibility here is 0, and there is no mutually orthogonal Latin square. For 3 by 3, there are two mutually orthogonal Latin square. The 0, 1, 2, 1, 2, 0, 2, 0, 1, and 0, 1, 2, 2, 0, 1, 1, 2, 0. They are called, these are all Latin squares because 2 appears only once in this column and row. For any number, 1 appears only once in this row and column. Similarly here, and they are called mutually orthogonal because all the pairs, when you superimpose one on another, all the pairs appear 0, 0, 1, 1, 2, 2, then 1, 2, 2, 0, 0, 1, then 2, 1, 0, 2, 1, 0. So this is 3 by 3 mutually orthogonal lattice squares, 2 of them. For 3 of them, one can work out this position. It cannot be 0, 2, it cannot be, it has to be, it has to be 3 or 1. But if you put 1 here, 3 cannot come here. So only possibility is 3. Now, this is a Galois field of order 4. These are the addition tables. And this is the 3 mutually orthogonal lattice square of order 4. Now you go to 5. First you try out the columns. Made a mistake. 3 is not possible. 2 times 1 is 2. 2 times 2 is 4. It has to be 4. Then 1 plus 1 is 2. 1 plus 2 is... Oops, it's taking time. The software puts the unique choices. Wherever there is a unique choice, it puts that number there. So 4 and 0 are the unique choices because 1, 2, 3 cannot be there. These are Latin squares. So only possibility is 4 here and 0 here. So this is 2 plus 1 is 3. Then 2 plus 1 is 3. This is the Galois field of order 5. These are the addition tables. And the first row is the multiplication of the first column is the multiplication of the first column here with different elements. So here you get all the 3 mutual orthogonal Latin squares of order 5. There can be at most 4 of them. Now for 6, you don't have mutual orthogonal Latin square. That is proved by exhaustive computation. So counting the number of Latin squares of order 6 is an interesting problem. Then you go to 7, where you can again use Galois field of order 7. The addition tables will give you mutual orthogonal Latin squares. Same is true for 8, 2 cube, Galois field of 2 cube. Then 9, Galois field of 3 square. For 10, the case is interesting. There is no Galois field since 10 is of the form 5 into 2. And you don't have mutual orthogonal Latin squares of order 2. So construction of mutual orthogonal Latin square of order 10 is a bit difficult, and that's a famous work by Professor R.C. Bose, Rikhande, and Parker. So you can start with learning how to construct 2 moles of 2 mutual orthogonal Latin square of order 10. And if you want to venture, you can try the third one, which we don't know whether the triplet exists or not. Most probably a triplet doesn't exist. That has been the conjecture, or one can put some effort towards that. That's the venture to unknown. Thank you.